Hello, and welcome to Data Understanding and Visualization in Python for Beginners, Part 2. In Part 1 of this series, we basically discussed some of the basics of NumPy and Pandas for data manipulation. In particular, we basically started NumPy by using arrays, by creating arrays from lists and tuples. We then talked about dimensions and shape and the accessing different elements in multidimensional arrays. We also talked about some of the useful functions available in NumPy, including a range function, the random module, and reshape function. Then we talked about the slicing in NumPy, and we also discussed the difference of slicing in NumPy and the ordinary lists in Python. Then we discussed basically masking, or sometimes called the fancy indexing, in NumPy, and we discussed how this kind of indexing differs from the ordinary slicing in terms of creating a copy rather than a view. Then we talked about broadcasting and some other universal functions in NumPy, and we then switched our discussion to pandas. We start discussing pandas by introducing series object and some of its properties, including values and index. And then we switched our discussion to a two-dimensional or spreadsheet-like object in pandas, which is called the data frame. We discussed certain characteristics, certain properties of the data frame, and we saw how we can index different kind of data, columns, rows, or submatrices inside the pandas. We discussed also some possible source of confusion using implicit or explicit indices in pandas, and we encourage to use LOC functions or ILOC functions explicitly to mention whether someone is interested in implicit index or explicit index. We then talked about some missing values, how to handle missing values, how to fill the missing values, and we also talked about the operations that can be performed on all the data values in a data frame. We also saw concatenating multiple data frames together, and then we talked about the group by function in data frame. That's very, very powerful function in arranging the results, sometimes summarizing the results, sometimes just ordering and arranging the results in a particular desired way. And then finally we apply some of these concepts on a CSV file. Basically we actually run some of these functions on adult data file that was available on UCI machine learning repository, publicly available data file. We actually read that data file, we do some processing on that. Primarily we converted at least one text field to one hot encoding numeric field, and then we saved that file to another CSV file, just for an example. In this particular video, or in this particular part of the series, we are going to talk about visualizations that are available in Python. Basically, we'll be discussing primarily we'll be focusing more on Matplotlib. That's a very powerful package in Python for visualizations, but we will also be discussing its comparison with Seaborn, and for interactive plotting we will be discussing Bouquet as well. Although there are other ways, there are other packages for plotting as well. Even the plotting can be done directly from pandas. I mean, pandas has its own plot functions, its own scatter matrix functions, and a lot of plotting support is available inside pandas as well. But in this particular video, we'll be actually focusing more on basics of Matplotlib, Seaborn, and Bouquet, and the discussion of in-depth plotting through pandas and also through these kind of packages will be deferred to our full-fledged course on AI sciences, where we have explained all these things in a greater detail. So let's start by package Matplotlib. So basically we have this Matplotlib package already installed inside packages. And this one function that is much more important in that, although there are so many, is pyplot. So one way is to just import this matplotlib.pyplot as PLT. That is kind of standard. There are a lot of styles that we can use for in Matplotlib. The styles, the graph styles. Here I have used this one, but there are so many others. Then there are two important functions. One function is figure that actually handles that actually acts as a container to hold all different kind of plotting objects inside, and another kind of function axis returns an object ax or axis plt.axis class object that actually handles all the x-axis, y-axis, and box kind of representations inside the plot. So let's go to our friend Jupyter, and let's just get started with this Matplotlib. So let me just yeah. So let me first import matplotlib.pyplot as PLT. Let me do that. And then there are so many styles that are available. So let me see what kind of styles are there. So style dot available, yeah. So let me just print those. I guess I have made certain spelling mistakes. Yes. So there are a lot of styles that are there that are available. For example, BMH Classic, dark background, fast. A lot of those, and one can prefer one style over the other in certain situations. For example, here I'm going to use style, for example, plt.style.use. That use function allows you to which kind of style I'm interested in. So let's just see born white grid. So let's say this is the style I'm going to use. And let's draw our first basically plot, the empty plot. Let's just plot our first figure by having this, and ax is equal to plt dot axis, and this actually shows our very first figure that has nothing in it. So yeah. So all the contents inside that will be handled by a figure object, and all the boxes and bounding boxes and axes, they will be handled by this AX object inside. So yeah, so that's our very first plot. So let's dive into some more interesting plots in Matplotlib. So let's generate some data point and apply some function on that and see how can we. So let's import NumPy, and that just to generate some data as np. Just import that, and now let's say we have x equals np.linspace, generate points starting from, let's say, 0 ending at 10, generate, let's say, 1000 points, generate those many points, x, and y is, let's say, simply np.sinx. Let's say these are my y values. And now what I do is I basically generate figure as plt.figure. Come on, that's a function, and ax is simply ax plt.axis. And then what I do is ax.plot, that's my function, x comma y. So this basically gives a very first plot that is available to you. So remember, I have called this plot function from AX object rather than the FIG figure object. Rather than using this figure function separately or axis function separately, you can have the same kind of thing directly from PLT. So for example, let's say you have this data XY available. Let me regenerate this data. And then you simply use plt.plot, and the same thing happens. Sometimes working with figure object independently and axis object independently become more fruitful but you can just use plot function directly from PLT and you're just good to go about that. So that's our very first plot. Next, let's move towards, plots, multiple plots. Maybe we can have many more plots on a single plot. On a single figure, maybe we have many more plots. So we have X, Y. Let's generate a Y2 as well. And let's see, oops, what happens. Yeah, Control C. Let's just move to our next figure. And let's say this is my Y1. And let's say I have Y2 as well. So Y2 is simply np.cos x, let's say. And then what I do is I plot Y1 separately and I plot Y2 as well. And the same thing, both of the things, they will get plotted on the same plot. So that's the plot that is available. Yeah. So even if you have more plots, for example, if you have Y3, let's say Y3 is equal to, let's say, Y1 plus Y2, let's say that's your Y3, you can have that plot as well. So plt dot plot xy3, and automatically it will be having a different color, and you can have several plots on the same figure. Yeah, great. So you can, and you can have the axis object, and you can do the same stuff using the axis object as well. So next, we talk about some of the styles that are available. For example, there are several colors. Here you have seen the colors are assigned automatically. This blue color, this green color, and this orange color, they are assigned automatically. However, you can actually specify the styles yourself. You can actually specify the colors yourself. So for example, let's take an example. plt.plot x values already generated, y values of y1, let's say, already generated, and let me specify that I need the color for this particular plot to be blue. And then plt.plot, for example, xy2, and you set, okay, the color for this particular plot I want green. So you can specify the whole green yourself, or you just write the G letter, and that means green by default. And you can have, for example, plt.plot, and you can specify the color for the third curve, maybe in a tuple, RGB value. All the values are between 0 and 1. So for example, 0.5, 0.8, and let's say 0.4. That might be in RGB values for the color. So the color, you can specify color in full strings, their initial letters, tuples of RGB, and there are other ways of specifying these colors as well. So now you can see, so the colors we specified here actually more resembles to green. Let me reduce the green component. Let me reduce the green component to 2, and maybe you get a different color. Yeah, cool. So now you have a blue color, you have a green color, and you have some color whose RGB value is this. These are not just the colors. You can specify the line styles as well. So for example, if you want, for example, here all the lines are solid. They're connected solid lines. What if you want the dashed lines? The plot, they appear in as a dashed line. So for example, plt.plot, you go for, let's say, x, and let's say x plus 1 maybe, and you say, okay, my line style that I want is should be solid. In that case, the line style will be, oh, well, what's the problem? Here is, I got some line style. Oh, yeah. So that's a solid line. If you, for example, change it to dashed line, for example, here, dashed line, then it will appear like in a dashed way, this way. And if you change, for example, this to dash dot, dash dot, and then you will get dashes, then dots, then dashes, then dots, and so on. And by the way, I mean, this can be anything. Maybe this can be Y that you have just seen earlier. You can have these dashes and dots. Wow, why not? And maybe you can have just the dotted line. I mean, just the dotted one. So dotted, all the dots. So dash, dots, solids, and then you can have these color properties. You can write, okay, color is let's say green, and so color properties there, these properties. So you can use both of the properties in combination. And there are shortcuts as well. Rather than writing all these dotted and dashed and all that stuff, you can just specify. For example, you can go and specify, okay, I want a dotted line. So for dotted, you just write a colon and you get the dotted line. If you want solid, for example, you just write a hyphen symbol and you get the dotted line. If you want a dash line, you just write the hyphen symbol again and you get the dashed line. If you want a dash dot, you write first dash and then dot, and you have this particular thing. You need not to actually specify the colors separately either. You can have, for example, plt dot plot x, y, 1, and you just say, okay, I need a solid green, and you will be having a solid green. Or you can have, for example, a dashed red, then in that case you will be having a dashed red. Or you can have, for example, dotted plot with cyan color, and you can have a cyan dotted. Yeah, I mean, a lot of things. Or you can have a dash dot, why not? You can have a dash dot in color. Let's say the color is black. So black is specified by K. So yeah, so you can have a lot of styles. You can have a lot of colors, all these combinations with very smart kind of commands. And you can have multiple of those. For example, if you have PLT, you can have multiple plots and different kind of styles and colors together. And you want here, let's say, dotted green, that is there. And then you have PLT dot plot x, let's say y3, and you have, let's say, this one as dashed, let's say red. And yeah, I mean, all these things in a single plot with different kind of styles and colors that you have specified. Yeah, so I mean these things are available. Not just these, you can set the limits. You can set the axis limits, for example. For example, you want your axis, rather than going from, your axis right now is going from 0 to 10, and that may be because the x you have generated is between 0 to 10. You can set your axis yourself. So for example, you can just write here plt dot x limit, and here you can set the limits of your axis. For example, -5 to 15. These are the axis limits. And now you can see the plot actually starts from -5 and go to 15, because you have set the axis to start from -5 and 15. But because there was no data point that was there in this particular area, you're no longer seeing any graph there, but you can set the axis if you want. Further, you are seeing that the y-axis is going from -1.5 to 1.5. You can set that as well. You can say, okay, plt dot y limit, for example, let me go from -3, let's say -3 to 2.5. So you can do that as well. In that case, you can see your plot. I mean, it looks like that. In the area of interest, you have a lot of plots, but inside because you have extended your limits, you have just wasted some of the space here, but maybe that may be required for certain kind of intuition or stuff like so. I mean, who knows? We can have another command. For example, let's say let me go into the next plot. We can have some pre-specified properties as well. For example, plt.axis, that's a function axis, and if we give in this particular axis, if we give, let's say, tight, that means x-axis and y-axis, they both should be tightened around the values that are actually there inside the data. Not just tight, we can have equal, equal, equal. That means x and y, they should be plotted to just match the aspect ratio of the screen and stuff like so. So sometimes these tight and equal, they may equally required. I mean, they may equally required. There are other tricks as well. For example, you can reverse the plot just by reversing the limits. For example, let me plt.plot, let's say x and y1, and let's say the color is, let's say x and y1, and I want that all as dash dotted, let's say red. And then what I do really is I actually reverse the limits. What I do is plt.xlimit, and I say, okay, go from 10 to 0 rather than 0 to 10. And what it does is actually reverses the graph along x-axis. Not only that, if I just reverse the axis, these limits, just limits, in y-axis as well, for example, go from minus 1.5 to minus 1.5. The whole graph will be flipped upside down. I mean, like you have taken the reflection of it from the origin. I mean, you can just specify the limits, x limits and y limits, and you get really the different effects and results altogether. We can actually annotate the graphs, for example, by specifying here some string that represents the x label. We can specify here some string, for example, that represents the y label. We can set the whole title of the figure. If we have multiple plots, we can specify the multiple plots with respect to their labels. So all these, let me give you an example to do all that kind of stuff. So let's see, plt dot plot, let's say x comma y, x comma y1, and let's say this plot I want really is in dash dot red, and this plot I just call this plot as, let's say, sine x. Let's say this is that plot. Next, let's say I have plot x comma y2, and I want this plot as solid green, and let's say the label of this plot is sine x, cos x. That is cos x. Cos x. Why this is green? Oh, yeah, that's fine. So plt dot plot, let's say x comma y2, y3, let's say, and let's say this is dotted black. This is dotted black, and let's say the label or the type of this particular plot is, let's say, sine x plus cos x, let's say. And what I really do is, what I do right now is I basically let me set the axis as tight. Maybe let me set these axes to be tight. Maybe I can specify the limits by myself, but I can do that as well. Plt dot title. What should be the title on top of the figure? Let's say sine and cos plots. Let's say that's my title. I can set the label on x-axis label, let's say label, let's say I call that as x. I can set the label on y-axis as well, let's say plt dot y label, that is, let's say y. And what next? Let me set the legend as well, plt dot should I specify this y, or should I call it as sine x, cos x, and maybe sine x plus cos x. These are, because these are my y values. Let me just show you that, and things will get clear. So legend command will actually specify these kind of labels in these kind of styles to know which curve represents what. So yeah, so let me run this, and you can see a very fancy plot here. Yeah, so let me zoom it down so that, yeah. So now you can see the x-axis label got this x, y-axis label got this whatever string we gave it, and the title, this is the title of the figure, and here this particular pattern is for sine x. Remember this we gave as a label here. Whatever the label string is, that will be printed. So that's the sine x here, and that's the cos x in green, and the dotted black is basically sine x plus cos x. So we can annotate our graphs as no problem. I mean, and many times this annotation basically is required. Further, I need to also specify some of the differences between PLT functions that can be used and the axis function that can be used. For example, let's say let's say fig is equal to plt dot figure, and let's say x is equal to plt dot axis. By the way, make sure that when you make this axis object, this is ax ex, and when you set the axis limits, that is ax ix. So be careful. I mean, maybe you just switch those two and you get horrible kind of results. So focus on e and I, the difference of e and I. Now let's say we have ax dot plot, for example, x comma y1, and then we can have ax dot, for example, set x label, let's say x, and similarly we can have ax dot set y label, and let's say that is y. So we can have this particular thing, and we have this x label and y label available. Equivalently, as we saw earlier, we can set these x and y labels using PLT as well. But in particular, in some of the cases, for example, when we talk about x label and y label, we cannot use directly ax dot x label as we have used plt dot x label. For x label and y label, we have to use the set underscore prefix there. Although other functions, for example, x limit, y limit, and title, if you use set x lim, set y lim, set title, all they work the same as in ax. Not only that, we can apply a set function in general, and we can set a lot of properties by applying the set function in general. Although the same kind of thing can be achieved from PLT as well, but using this axis object, we can do the same stuff as well. So let's see, ax is plt dot axis, and then we have ax dot plot. Let's say xy1. Let's say I want that to be dashed red. Okay, so then I can set ax dot set, and then I can set a lot of properties here. For example, I can set x limit to be 0 to 10. I can set, for example, y limit, that's a property, to be between, let's say, -2 to 2, or maybe I can set the x's to be tight or stuff like so. I can set the x label as any string, let's say x or anything, let's say, I can set the y label as whatever string, whatever descriptive string I want. Not only that, I can set the title as well here. That's my title. So I can do all that stuff. Oh, there is some error. Yeah, here is the error. Yeah, title is this. So now you can see each and everything is basically, so you can use the access object, or you can use the pyplot plt alias at the same time, and everything works just as it is. Next, we discuss a lot of different kind of markers that are available. For example, maybe we want, rather than this continuous kind of plot, maybe we want some scatter kind of plot. I mean, the plot that just represent, rather than these dashed and dots, maybe there are other symbols that are available. Just take, for example, we have, let's say, plt dot plot x y1, and we just say, okay, my marker is just the points, and the colors are, let's say, black. In that case, I'll be having a scatter plot. This is no longer scatter, and the reason is there are a lot of points there. So let me generate a few points just to show you that this indeed is a scatter plot. So x is np dot linspace. Let's say start from 0 to 10. Let me generate just 20 points, and let's say y1 is simply np dot sin x. So now if you see, I have these kind of all these points that are available, just like they're not connected, and they act like a scatter plot. Although PLT has a scatter function itself, but you can use these different markers to just get the kind of look and feel that you really want. And there are several markers that are available. For example, if I just played a dot there, it will print all these markers in dot. If I print this, for example, X there, that's a different kind of marker with all the X's. If I print, for example, here a plus, that's again a different kind of marker. All the points are displayed as plus. I can have this, I mean, there are so many markers there. I can have this V, for example, and that is the triangle, this kind of triangle. I can have this, let me show, yeah. I can have this uppercase, for example, this power symbol, and I can have the triangle up with the top corner up. I can have this kind of triangles. I can have this kind of triangles. I mean, so many of them. And I can have this squares, or I can have these diamonds. Yeah, so I mean, so many of them. Let me just play with all these kind of markers that are available. Let me just write a program to actually show you some power of using this different kind of markers together. So let's say we have this marker array, marker list markers, all the markers. Let's say we have these. Let's write all the markers. Let's say O, that's a marker. We have dot, that's a marker. We have actually comma, that's also a marker. We have, let's say, X, that's a marker. We have, let's say, are you seeing it properly? Yeah, should I? Yeah, should I? I guess I should zoom it up. Okay, then we have this plus, that's a marker. Then we have, for example, this V, that's a marker. This sometimes used as a power symbol, that's a marker. We can have another marker, for example, this kind of triangle. We can have a marker like this kind of triangle. We have squares. We have diamonds. Yeah, so let's have these markers available. And what we really do is we generate, let's say for markers in markers, what we really do is plt.plot np.random.rand. Let's generate x-axis just by random 5 numbers. Let's generate the y-axis by random 5 numbers, and let's say 5. And then what kind of marker we are going to use is M, and label is simply label is also M. So let's do that and see what happens. So you see that, oh, we haven't applied the legend. Let's have legend at the end, plt dot legend. So yeah, I mean, these are all the legend. The legend is available here, and here you can see all of them in different kind of colors, different kind of markers, all the random data. Yeah, so yeah, I mean, you can use here I have just plotted the data just randomly, but I just want to show you that we can have, for example, all these kind of stuff available, or we can use any kind of labels at any time. We can use any kind of markers, any kind of colors. I mean, we can have lists of colors, arrays of markers. We can use these dynamically in loops and stuff like so. So they are really powerful. I should also mention here that this is not just the markers that actually specify the scatter kind of plots. You can actually PLT has its own scatter function. So for example, PLT dot scatter, that's a function. So xy xy1, I guess. What kind of data set I have generated earlier? xy1, yes. So xy1, for example. And if you want color, for example, color here. So let's say color is red. The size, if you want different sizes, so size might be, let's say here I have size, let's say 50. And if you use alpha blending as well to see through, let's say that is this 3. And you can have a lot of color maps. So here we have color map, for example. If I use the color map as where ID is, yeah, so also I can have a color bar available if I want to. Just do, yeah, so I have all these colors. I have all that thing available. That is my color bar. That's my scatter plot. If I just change the size, these points, they will blow up just on a larger size. I can have different kind of colors. I mean, I can use, for example, a color just as let me show you really. The colors might be just to use, let's say np.random.rand, let's say colors 30. Let's use the random colors, and sizes, maybe I can use the sizes as, let's say, the random sizes depending upon let's say 100 times np.random.rand. Let's say 30 of those, because I have 30 points. I can use random sizes for different kind of points, and random colors. And in that case, the plot, oh, oops, there is some error. Let me see what kind of error I have done. Color keyword must be MPL color spec or sequence of color specs. Yeah, I mean, I have not used, maybe I have done something wrong. Oh, if I have to use this multiple colors, I have to use C rather than colors. Oh, so yeah, I remember that. I have to use C rather than color if I have to use a list of colors. So I guess it should work now if there is no further bug. So let me see that. So now, if you have seen, it's a cool kind of plot with different sizes and different colors on different, and these are the color bars that are available. If you really want to know what kind of color, what kind of color maps are available here. We have used this particular color map. There are a lot of color maps. For example, plt dot, let me just check, cm dot all. So these are all color maps. So you can see there are so many of them. So many of them. Different. You use different color maps, you get different kind of results there. Yeah. So there are a lot of color maps here. So I have used simply just I have used this particular color map. Yeah. So if I for example increase the value of this alpha, you will see more kind of solid colors rather than opaque of those. So now you can see those. Yeah. So, and further, you can have multiple plots again on the same kind of regime that we have seen earlier. So that was about scatter plots. Let's see also just an example of contour plots as well, because we are just moving towards plotting in a bit detail. Let's see some contour plots as well. Just to show you also the power of plotting, and another changing the color map, how it affects basically all the visualization. So let's say we have x as random and p dot or linspace, for example, generate some points starting from 0, ending at 5, generate let's say 50 of those. And let's say we have y as let's say np dot linspace, generate some points, let's say starting from 0, let's say ending at 5, and generate let's say 40 of those, 40 points, equally spaced points. And then we can have xy as a mesh grid, np dot mesh grid xy, that basically generates all the grid starting from this x and y. See, we have 50 points starting from 0 to 5. So maybe the first point is 0, then the second point maybe is 0.2 and stuff like so. Then we have independent y points, but we need a grid of those. So for example, if we just, oh, I have an error. Wow. Linspace. Maybe I have used some spelling mistakes here. Oh, this E is not there. Yeah. Yeah, sorry. So now if you see this x basically is the idea of mesh grids. Let me give you the idea of mesh grids. Just let me reach. Yeah, the idea of mesh grid is, let's say you have this particular x is, let's say this is 1, 2, 3, and 4. Let's say just 4 points in x, and let's say the y is, let's say 0, 2, 8, and 7. Then what mesh grid does is it actually make different points with 1 and 0, that's 1 point, 1, 0, that's 1 point in xy space, then 1, 2, that's another point, 1 with 0, 1 with 2, 1 with 8, 1 with 8, and then this 1 with 7, then this 2 with 0. So you can think that as a Cartesian kind of product. I mean, it makes a whole grid centered at these kind of points. And on these grids, you can define some function. For example, the function might be simply x plus y, or it may be some arbitrary kind of function. And then you can see the contours, where the contours just actually are the values where the function has the same. What are the input values where the function output is the same? So for example, if this is the output of the function, if this is the z value, for what pair x and y the z values have the same value, those levels where the z values are same, they are called contours. And in PLT, there's a contour function alone. There's a contour fill function designated by this f. So let's see that. Let's see that in Jupyter Notebook just to see how cool that is. So let's actually plot this function. So let's say we have mesh grid now available. Let's say z is 10 steric np dot sine x plus let's say 2 steric y, let's say that's our z. And what we really do is we plot plt dot contour fill x, y, and z, make 20 intervals, equally spaced intervals, and set the color map as RD GY. There are so many color maps. Let's say this, and also plot the color bar as well. So color bar. So let's see what happens. Oh, you see that? I mean, these are the contour plots. How cool is that? Oh my God, that's awesome. Let me show you that. Yeah. So these are all these curves. I mean, the curves with the same kind of color. They specify the value of x and y, where the z value is the same. So we can have, for example, plt.x label as x, plt.y label as y. Maybe this should be a string, x and y. And we can have a title as well, plt.title as contour plot. So now if you see, we can have a little bit annotated plot with this. This is my x, this is my y. The total number of intervals, if you count, there are 20. If we reduce this value from 20 to down, you will be seeing less intervals. For example, here you see only 10 intervals. Yeah. So if interval means the whole x space is divided into how many intervals to make these contours. Similarly, the y. If you increase that value, let's say from to 30, you will be seeing more fine-grained intervals and more kind of continuous switching between different contours. Yeah. So yeah. So that's the contour plot.